The last part about a linear function is that it is considered continuous. I think we talked about this with domain and range, continuous versus discontinuous. Remember, continuous does not mean goes on forever. That's the number one misconception that students think. Continuous means there are no gaps or breaks. Again, continuous, no gaps or breaks. So the arrow on this side is one end of this graph. I put my pencil down. I can draw the entire representation of this without ever picking my pencil up. If my paper were bigger, once I started drawing the line, I would be able to draw it continuously without ever having to pick my pencil up. That's why it's continuous. Next parent function is the absolute value parent function. It looks like a V. The equation is f of x equals the absolute value bars. Those are straight bars. You have that on your calculator. You can do that on Desmos as well. So it's the absolute value of x. Again, the domain is all real numbers, and you know it's all real numbers because you've got an arrow pointing to the left. That means I'm starting over here at negative infinity, and I'm going all the way over until it hits 0. Then I'm continuing along until positive infinity. There's an arrow on the right. So I'm using the entire x-axis to graph this function. So it's all real numbers. If you're going to put it in interval notation, it would be, of course, negative infinity to positive infinity. The range, however, is not all real numbers. The range, if you're working with this problem, you're going to remember range reads from the bottom up. So you start looking at the bottom of this graph for the function. There's no function down here whatsoever. Here's the first place you see a function, and that happens on the y-axis at 0. And then, of course, as you move up the y-axis, you've got a function on both sides. So the y values start happening at 0, and then they continue to go up. Those arrows are pointing up. So it's y values that are greater than or equal to 0. That's inequality notation. If you wrote this in interval notation, we would start at 0 and we would include 0. That's why I have a bracket. And then we would put a comma, and then we'd put infinity. Infinity always gets a parentheses. The x and y intercept again is 0, 0. One thing I didn't mention, all of these we usually have 3 points that we use to identify each one of the parent functions, and we usually use the points right around the origin. So we use -1, -1. We use, and this one is 0, 0, and we use the point 1, 1. The reason that we look at ordered pairs to help us graph it is because we're going to start transforming these real soon. And if we get the general idea of what the shape should look like, it doesn't matter where we move it, we can still have that middle one, and then we're going to go up 1 and over 1 and go down 1 and left 1, and we get those other 2. That's more to come later, but we usually have, like I said, 3 points, and those 3 points on this one right here would be this one. So the x values would be -1, 0, and 1, and the y values are 1, 0, and 1. That's those 3 points right there. The maximum number of times that this graph could cross the x-axis, here let me draw you an example. There's an absolute value. It crossed the x-axis right there and right there. So at most, it can cross the x-axis 2 times. It doesn't mean that they all will cross it 2 times. The parent function itself crosses the x-axis only once. And here's an example of an absolute value graph that doesn't cross the x-axis at all. So remember, this says the maximum number of times. It can't cross it more than twice. Again, let's look at in behavior. In behavior, this is going, and you can remember, use your little easy words. On the right side, it's going up, and on the left side, it's going up. Okay, so the arrows are going up on the left, up on the right. So all you have to do is know the symbols to rewrite that word right. How do we write the word right? If it's right and left, if it's going to be an X symbol, so we say X approaches, and if it's going To the right, we're going to infinity. So as x approaches infinity, that this right here is saying right. And this is saying up. On the right side, we're going up, and on the left side, we're going up. We call this, this up here, if I ask you to describe the end behavior, I would say different. It has different end behavior. One side's going up, the other side's going down. For the end behavior here, I would describe that as same end behavior. Same end behavior, because both ends are doing the same thing. Both ends are going up. Okay, I'm going to scroll this up so you can see, went too far. You can see both, we've got quadratic and cubic equations. The quadratic looks has a lot of characteristics like the absolute value. It is in the shape of a U though. It does have a curve in the bottom and it's always curved. As a matter of fact, when we start graphing quadratics, people are going to give me little pointed things and I'm going to say it's not a point. You have to have that curve. Notice the domain and range is exactly the same. So be sure you can write that using interval notation. The x and y intercept is exactly the same as the absolute value. The maximum number of times it cross the x-axis is the same. Again, that's because I could have one that does this, and then I could have one that does this. So we could cross it twice. We might only touch it once, or we could not cross it at all. But the maximum number of times that a quadratic is going to cross the x-axis is 2. It also has same end behavior. On the right, we're going up. Remember, this says right and up. And on the left, we're going up. That says left and up. On the left side, we're going up. I'm sorry, I got interrupted. I'm not sure where I was. I think I was talking about end behavior. So on the left, this part right here says left. This notation right here says up. And because I'm going up on the right, x approaches infinity is how I say right. And f of x approaches infinity is how I say up. Notice that when these two match, we say it has same end behavior. It is continuous because once I put my pencil down, I can trace the entire graph without having to pick up my pencil. The cubic function is f of x equals x cubed. That's why it's called cubic. It has a little wavy wave. Notice the three ordered pairs are exactly the same as the three ordered pairs that we did for the linear equation. As a matter of fact, when I'm drawing this, I usually start off with the little linear part right there, and then I curve it quickly up and I curve it quickly down. That kind of helps me get that curve in there. But this middle part right here does look a lot like the linear function, but it is just a little bit curved. It does have because it has a different end behavior, it is going to have the domain and range of all real numbers. Remember, that means negative infinity to positive infinity on both of these. I'm not going to write it every time, but I am expecting you to be able to write it every time. You are responsible for knowing both notation. And by the way, if you just wanted to write it all out using words, you would simply just write the words all real numbers. Okay, it has the same x-intercept as at the origin, since it's passing through the origin. This one can cross the x-axis at most 3 times. Now this one's only crossing it once, so it's like the others. It doesn't have to cross it at 3 times, but I could have a cubic that looks like this. So it kind of passes it. There's one x-intercept, there's a second x-intercept, and then there's a third. But that's the most it can do. We'll study a lot more about cubics and other graphs that have these humps and turn around and all that kind of stuff when we study polynomials. The end behavior is different. So it's going to be the same as it was the linear. This says right here, you should be learning to read this on your own, but this says on the right it's going up, and on the left it's going down. Um, that's what we understand it to mean. That's not how it reads. If I actually ask you to read that, you would say as x approaches positive infinity, the function approaches positive infinity. That's how it reads, but we know what it means. This means on the right it's going up, and on the left it's going down. It is continuous because you can draw it without picking up your pen.